Hello everyone, I'm Dr. Shaibi. Today we are going to learn about the term called rate of change. As many of us have come across this term, but today I'm going to discuss about the exact meaning of rate of change. So let us look on to the our real life where this rate of change is occurring. Let us look on to the first example of speed of a car. So if a car covers 120 kilometer in 2 hours, then its speed would be 120 by 2. That is average of 60 kilometer per hour is the speed. Now let us look on to the second example, filling of a water tank. So here, if 750 liters of water fills in 30 minutes, then the filling rate is 750 by 30, that is 25 liters per minute. Here, this is the third example, the temperature change. That is, if the temperature rises from 20 degrees Celsius to 32 degrees Celsius in 3 hours, then the rate of increase is 32 minus 20 and divided by the total 3 hours, which means 4 degrees Celsius per hour is the rate of change. Now, in these three examples, here the speed is the rate of change of distance with respect to time. Here, filling rate is the rate of change of amount of water with respect to the time. Rate of change of temperature with respect to the time is 4 degree. So here we can observe that the rate of change is nothing but change of one variable with respect to another variable is considered. So in a mathematical form, the rate of change is the change in one quantity divided by the change in the independent quantity. So del y by del x. So this is the foundation of the calculus. So as per the formula we have discussed earlier, the average rate of change is del y by del x, which is the function of two distinct points x1 and x2. So f of x2 minus f of x1 by x2 minus x1. Now the question is how we can find the rate of change at one particular point. So let us observe and understand that with the help of an example of simple function, let us take y equal to x square. So here, this is the plot of the function y equal to x square. Can you observe here, for the point at x is equal to 0, the function takes 0. And for the point 1, it is 1 square, so the answer is 1. And for 2, it is 4. And for 3, it is 9. Now we can see that from the point at x is equal to 0 to 1, the graph rises only little. And from the point 2 to 3, we can see that the graph rises much more, which means the curve becomes steeper as x increases. So the rate of change is, as we discussed del y by del x, from now on we will be using one term called rise and run. So del y is nothing but rise and del x is nothing but run. So rise means how the function rises, I mean in the vertical form, and run is the function, the point changes in the horizontal form. So now let us understand this rise and run with a simple example from the point x is equal to 0 to 1. So now consider the point 0, 0 and 1, 1, which means at this function y equal to x square, at the point x is equal to 0, the function gives 0. And for x is equal to 1, the function gives 1. Now run means from the point 0 to 1, this is my run, and rise is vertically moving. So in the distance of 0, 1, the run is the distance. So 1 minus 0 is 1, and the rise is, according to this graph, at the point x is equal to 0, it takes 0, and for x is equal to 1, it takes 1. So the rise is nothing but 1 minus 1 is 1. Sorry, it's 1 minus 0 is 1. Now let us calculate the rate of change. The rate of change is rise by run. So here the rise is 1 and the run is 1. So 1 by 1 is 1. Now here the observation is for every one step to the right, the graph goes one step up. Now let us understand this exact meaning with the help of another distinct point. Let us take x is equal to 1 to the x is equal to 3. Now, according to this function, if I take x is equal to 1, it gives the answer as 1 for y. And for x is equal to 3, it gives the answer as 3 square, that is 9. Now, from the point 1 to 3, you can see here from 1 to 3, the distance of my run is 3 minus 1 is 2. And for rise, please and remember that we are looking from 1 to 3. So here the run is 3 minus 1 is 2 and the rise is, as we can observe here, is at the point x is equal to 1 it gives 1 and at the point x is equal to 3 it gives 9. So for the rise it is 9 minus 1 is 8. Now let us find the rate of change. So it is rise by run. So 8 by 2 is 4. So according to this, the meaning is for every one step to the right, the graph goes 4 steps up. So now let us understand this meaning. What is the meaning of this rate of change 4? And here we have seen the rate of change is 1. Actually, the exact meaning is just consider the distance of what you are having in run. Say for example, from the point 1 to 3, the distance of my run is 2, which means I have to take every jump of 2 units. Say for example, see here I am considering for x is equal to 1 and x is equal to 3. So I have to consider the distance of run is 3 minus 1 is 2, which means for every jump I have to take 2 units, or 2 steps. So let us have this observation in the changes in the graph. So from 1, I have to consider 2 steps as 1 jump. Remember, 2 steps as 1 jump. So here, first step, second step. So this is my first jump. Then first step, second step. This is my second jump. First step, second step. This is my third jump. And first step, second step. This is my fourth jump. I hope you all can able to understand what I am trying to say. Like I repeat one more time. From the point 1 to 3, we have to observe the rate of change happens for the distance of 2 units, which means for every jump I have to consider 2 units. So for each jump 2 units is considered. So 1, 2, first jump, 1, 2, second jump, 1, 2, third jump, 1, 2, 4 jumps, which means for the points 1, 2, 3, for the 2 units, the rate of change is 4 units. So that is the meaning of rate of change. So that is the meaning given here. For every one step to the right, the graph goes 4 steps to the up. So this is the average. So here if I consider from 1 to 3, the distance is 2. If the 2 units distance is considered as 1 jump, so here the 4 jumps has been done in the graph. So that is the meaning of having the rate of change. So for one step to the right, the graph changes for 4 steps. So that is the exact meaning of rate of change. So as the average rate of change, we can observe for the distinct points 0 to 1 and 1 to 3 and 2 to 3. So if it is for 0 to 1, it is the run is 1 minus 1, 0 is 1 and the rise is 1 minus 0 is 1. So the rate of change is 1. If I consider for 1 to 3, the run is 2 units and similarly for 9 minus 1 it is 8. So 8 by 2 is 4. And similarly, if I consider for 2 to 3, here we can observe that from 2 to 3, the distance I am moving in run is only 1 unit. So while I consider for the jump here, I have to consider 1 unit for 1 jump since I have only 1 unit for 2 to 3. So if I consider from 2 to 3, the distance I run is only 1 unit. So let us observe here from for the point 2 it is actually 4. So for the point 3 it is 9. So I have to consider from 4 to 9. So since I want to consider for one jump as 1 unit, so here to here is first jump, second jump, third jump, fourth jump, fifth jump. So that is the observation that we are having here, which means This is the exact rate of change. That is how many units you are moving in the running. You just consider those units as one jump. According to that, you should move in your graph. So that is the exact meaning of rate of change. Now let us have this rate of change in a numerical approximation. As many of you have come across this formula in our school days, like this is the left hand and right hand formula for finding the rate of change. So here it is, the slope calculated by moving towards x from smaller values, whereas here the slope is calculated by moving towards x from larger values. So let us consider this numerical approximation for the given function y equal to x square at x is equal to 1. So now let us find the derivative of the function y at the point x is equal to 1, which means here we have to consider both the left and the right hand. So now first of all, let us focus on to the right hand. So according to this, the formula is f of x plus h minus f of x by h. So this is the formula I am going to consider. So instead of x, just substitute 1. And now let us have the approximation value for different h. So now let us consider h as 0.1. So if it is 0.1, then here the function has to consider for the point 1.1. So one of the function takes 1.1 is 1.1 whole square, so it is 1.21. And according to the formula, it is 1.21 minus 1 by h. So h is 0.1, it gives 2.1. Similarly, instead of h, if I consider the smaller value, so it becomes 1.01. So square of this number is 1.0201. So according to the right hand formula, it is 2.01. As you can observe here is, when the h value becomes smaller, the answer is converging to the number 2. Here I can explain you with the even smaller value of h. So if I take h is equal to 0.001, according to the formula, if I substitute here, I can get the answer as 2.001, which means if my h is smaller, then the answer is converging to the number called 2. And similarly, like this right hand side, I can even consider for the left hand side. So here I have taken the right hand formula, but in the place of h, I am going to consider the negative values of h. Instead of this formula, you can either take this formula, but in the place you can substitute h as a positive number. Since I am having this formula, I am just substituting the value of h as negative number, so that both the things are one and the same. So I have taken the h value as minus 0.1. So if it is minus 0.1, so the point here is 1 minus 0.1, so it is 0.9. So the square of this number is 0.81. So according to this, so here it is f of x minus h minus f of x by minus h. So if it is happens, then the answer is 1.9. And next, let us consider even smaller of h. So h is minus 0.01. So according to this, the point is 0.99. So the square of the number is 0.9801. So according to the formula, the answer is 1.99. And similarly for h even smaller, I'm getting 1.99. So here I can observe that if my h is even smaller, that is converging to 0, when in the left hand side, my answer is converging to 2. And here in the right hand side, if my positive h value converges to 0, my right hand side limits are converging to 2. So which means the numerical approximation based on the formula gives the answer 2 at the point x is equal to 1. So this is the rate of change of the function y equal to x square at the point x is equal to 1, which gives the answer as 2. Now let us consider the same observation for the point x is equal to 2. So let us observe the function f of x is equal to x square, and for the point x is equal to 2, let us have this h 0.1, it gives 4.1, and for h is equal to 0.01, it gives 4.01, and for h even smaller, it gives converging to 4 near. And similarly for the left hand side, if I consider the left hand of 0, that is minus 0.1, it gives 0.9, and minus 0.0123, it gives 3.99, and for h minus 0.001, it gives 3.999. So here we can have a beautiful observation. Suppose in the right hand side, if my h converges to 0, the answer of the function at x is equal to 2 gives 4, or it is converging to 4. And similarly for the left hand side, if I take the h value which is converging to 0, the answer is approaching to 4. So here the observation we have to look upon is when h converges to 0, even left hand side or in the right hand values both converging to the number 4. Now the observation is why the rate of change looks in the form of 2x. So at the point x is equal to 1, we got the rate of change is 2. And for 2, we got 4. And 3, we will be getting 8. So here you can observe the pattern that here all the numbers have the answer to be a multiple of 2. So that is the rate of change happens here. So that's what the rate of change has come for the function y equal to x square as 2 times of the given number x. Now let us have this derivative for the function y equal to x square in a theoretical form. So we know y equal to x square, and the derivative formula is limit h tends to 0 f of x plus h minus f of x by h. So in the place, instead of substituting the value of h, let us solve it mathematically. And we all know a plus b whole square is a square plus b square plus 2ab. So instead of this, I am just going to replace this. So in the place of a, I have x. In the place of h, in the place of b, I have h. So if I replace that, it becomes x square plus 2hx plus h square. So if I substitute h tends to 0, here I have minus x square. So here also I'll be getting 1x square. So those x squares will be getting cancelled. So these two terms if get cancelled, the remaining terms I have is 2xh plus x h square by h. If I take h as common, I can get h into 2x plus h by h. So those h gets cancelled. So the remaining term I can get is 2x plus h. If I consider limit h tends to 0, I will be getting 2x. So this is the mathematical understanding of the derivative for the function y equal to x square. So that is how the reason for this function for getting the rate of change for each point as 2 times of the given point. So as a conclusion, we are getting the derivative of the function x square is 2x. Now let us have this understanding of rate of change in a real life application. So let us take a problem of a car moving on the road. Let us fix the time of 1 second. It covers of 10 distance of meter. For 2 seconds it took 25 meter, and for 3 seconds it took 45 meter, and for 4 seconds it took 70 meter. Now let us have the distance traveled by the car at the rate of change of time. So now let us consider for the distance of for the difference of time to minus 1 seconds, which means I am just going to consider the rate of change of the distance traveled by the car from 1 to 2 seconds. So the rate of change in time is 2 minus 1, so that is 1 seconds. And in this interval, the distance covered by the car is 25 minus 10, so it is 15. So the rate of change is 15 by 1, so it is 15 meter per second. And similarly for 2 to 3 seconds, 3 minus 2 is 1, and 45 minus 25 is 20. So for 1 second, the car had a rate of change of 20 meter per second. And similarly for 3 to 4 seconds. Here you can observe that if the time increases from 1 to 2, 2 to 3, or 3 to 4, if the time increases, we can observe that the speed of the car or the rate of change of the car is increasing. So this is the exact meaning of rate of change that we have come across. We are come acrossing this kind of real life problem or situation in our day-to-day life. So to be crispy, rate of change is how fast one quantity changes with respect to another. So this is the real meaning of rate of change. So I hope you all have understood that what is the exact meaning of rate of change with the help of simple example. Thank you so much.